Hi, I'm Amashni. Welcome to Lesson 3 in our series of lessons called Classification of Triangles. By the end of this lesson, you should be able to describe the characteristics of the isosceles triangle. We will kick off this lesson by trying to construct our own isosceles triangle. This is how we do it. We start off by folding EH onto FG. Like this. Make sure that your sides are aligned and do the fold. Then we fold HG onto EF. Alright, just be careful to get the sides aligned. So we find that we end up with two lines of symmetry. Remember that a symmetry line is a line that divides the figure into two equal parts. We mark off the symmetry line or the midpoint of both these symmetry lines here, and we mark it as point P. We will now join P to point H and P to G using our ruler. Okay, just make sure that your ruler is straight and join the points. Now joining P to G. And lastly, we join K to T, which is in fact the line of symmetry. Remember that for our model to be an isosceles triangle, we need to have two sides that are equal in length. Let's look at our model to see if this is true. Using our ruler, we will measure sides PH and PG. We see that PH is 25.5 centimeters. So let's write that, 25.5 centimeters. Let's measure PG. Side PG measures also 25.5 centimeters. Now before we cut out our model, have a look at this line KPT. We know that this is the line of symmetry for rectangle EFGH. But now, do you think that PT will be the line of symmetry for triangle PGH? I will use my tracing paper to trace out the triangle that we have. We said that a line of symmetry divides a figure into two equal parts. So, if PT is the line of symmetry in the triangle, it should divide the triangle into two equal parts. Now let's fold our tracing paper along the line PT to see if this is true. We fold. So do you see that the angles and the line fall perfectly onto one another? Now that we know that PT is the line of symmetry, what can we predict about angle PGT and PHT? Well, if PT is the line of symmetry in this triangle, it means that angle PHT and angle PGT are the same size, as they are mirror images of one another. Do you also notice that these angles lie opposite the equal sides? Do you think that these angles will remain equal to one another if we change the lengths of the equal sides? Let's measure the angles in a few examples of isosceles triangles and see if we can find an answer to our question. Here I have 3 triangle cutouts of isosceles triangles. I also have a table where I will record all the data I get from measuring these triangles. Let's look at the information that I've got. The data that we got from this activity makes it possible for us to make 2 very important conclusions about isosceles triangles. We can say that although we measured 3 different isosceles triangles, the angles opposite the equal sides of the isosceles triangle are always equal. And the 2 sides that are opposite the equal angles in an isosceles triangle are always equal to one another. The data from our table also tells us a very important thing about the types of isosceles triangles that we get. Have a look. In triangle 1, we see that all 3 angles are less than 90 degrees. This is called an acute angle triangle. In triangle 2, we see that one angle is 90 degrees. This is known as a right-angled isosceles triangle. In triangle 3, we have one angle that is greater than 90 degrees. This is called an obtuse angle isosceles triangle. Do you see that we have defined isosceles triangles into 3 types of isosceles triangles? This means that we can now develop our tree diagram with the different types of triangles. Previously, we saw that scalene triangles were broken up into acute, obtuse, and right-angled scalene triangles. In this lesson, we find that isosceles triangles can be broken up into 3 categories: acute-angled, obtuse-angled, and right-angled isosceles triangles. When we constructed our model of the isosceles triangle, we found that it had one line of symmetry, PT. Can you predict whether an isosceles triangle has more than one line of symmetry? Let's fold our model to see. I have cut out our model of the isosceles triangle. Let's try to fold to see whether we could get other lines of symmetry. If I take G and try to fold it onto P, we see that no, we can't get a line of symmetry. If I fold H onto P, no, we can't get another line of symmetry. So none of the other sides of this triangle form a perfect mirror image. So if you predicted no, there is only one line of symmetry, PT. You were absolutely correct. I would like to show you that the line of symmetry in the isosceles triangle does some very special things to it. Let's have a closer look. The symmetry line PT bisects angle HPG into 2 equal parts. We can say that PT is an angle bisector. As you can see, PT also cuts the line segment HG into 2 equal lengths. We say that the symmetry line PT bisects the side HG. Can you remember from lesson 2 what we called a line that passes through the vertex and bisects the opposite side? Yes, it is a median. So we can say that PT is a median in this triangle. Now PT also bisects HG in a specific way, at a 90-degree angle or perpendicularly. We say that PT is a perpendicular bisector. Now because the symmetry line PT makes this 90-degree angle with the opposite side of the triangle and also passes through the vertex, PT is also an altitude of triangle PGH. I'm sure that you remembered the terminology angle bisector, median, perpendicular bisector, and altitude from our previous lesson. Isn't it interesting that all of these lines coincide with our line of symmetry? But just remember that we can draw these lines for all the sides in the triangle. Let's recap what we have learned today. An isosceles triangle has two sides that are equal in length. In an isosceles triangle, the angles opposite the equal sides are always equal to one another. An isosceles triangle only has one line of symmetry, and there are three kinds of isosceles triangles, namely isosceles right angle triangle, isosceles acute angle triangle, and isosceles obtuse angle triangle. Thank you for joining me today. I look forward to seeing you in our next lesson where we investigate the equilateral triangle. Bye.